Hey guys, so we're gonna do integration involving inverse trig, okay, and advanced integration techniques. So remember that the advanced one is not that the test is gonna be filled with these, is that you need to be able to recognize it. So again, when you're looking at a question, when you integrate, don't just integrate right away. You wanna go through all of your options. Are you going to use the power rule? Can you use substitution? Does it look like it would be a trig, inverse trig? Think the 1 over the square root stuff, okay? So these are just some more integration things, but again, take your time. So with integrating a fraction where the degree of the numerator is greater than or equal to the degree of the denominator, you will have to use long division, okay? So here our degrees are the same, so we are going to do long division to set this up. So remember, your denominator goes on the outside here. Divide into x squared minus 4x plus 2. X squared times what is x squared? Well, that's just 1. So I'm going to go x squared plus 2, line them up. And remember, you're going to subtract straight down, so those cancel. Negative 4x minus 0 is negative 4x. And 2 minus 2 is 0. Be careful. Make sure you're subtracting straight down. Then what we're going to do is ask ourselves, what times x squared equals negative 4x? Well, we can't go to a lower degree, so that's kind of our remainder. Remember what we do with our remainders? We put it in the numerator, and we have the same denominator of x squared plus 2. So now what we're going to do is take our answer and do the integral of there. So we have the integral of 1 minus 4x over x squared plus 2. Now, the 1's easy because that's just our power rule. But here, what we might need to look into is say, you know what, I'm going to do some u substitution here and say u is x squared plus 2. So du is 2x dx. Okay, don't forget there's that dx there. So as you can see, this is like a 2 times du, right? So what we have here is the integral of 1 minus 2 over u du, okay? Now we need to think about is taking, and don't forget dx is still right here because we didn't do anything with u's over there. Sorry, guys. All right, so this is going to be ln. So think of this as the integral of 1 dx minus, I can bring that 2 out front, integral of 1 over u du. So when I take the integral, I get x minus 2. This is going to be ln now. Because I'm running out of room, guys, I'm not going to put the u here. I'm going to put what u actually equal to. And remember, it's absolute value, right? Of x squared plus 2 plus c. Now, one thing I do want to tell you, though, I did say absolute value because you want to always remember that it's absolute value. But if this were a multiple choice problem, you might not see that it has absolute value. Why is that? Well, guys, because x squared plus 2 can never be negative, so you don't have to worry about the negatives. That's the whole reason for the absolute value, right? So in a multiple choice, you might not see the absolute value because it doesn't necessarily need to be there in this case. All right, example 2. So think of this, that we have the 1/2 right here. Okay, now this is where the top is greater than because we have a fractional, okay? So what they're gonna do here is let's make this look a little bit nicer in this case, okay? Let's say u equals the square root of x dx. When I find the derivative, I get 1/2 x. Actually, wow, they did this a little bit weirder. I don't like this one. Sorry, guys, I'm thinking to myself really quickly. What they did, okay, again, these are the ones that you're hardly going to run into. What they did is they wanted to get rid of the square root here. So what they did is they squared both sides. And this is something that you can do. So if I squared both sides to get x, I don't know why I put the dx there, guys. Now take the derivative. That means I get 2u du equals dx. Now I'm going to substitute in. Again, I understand that this might be like, well, how do you know to do that? When we practice and recognize these a lot more, guys, it will be easier. But like I said, you're not going to run into a lot of these. So let me put this in. So we get integral. So dx is 2u. So 1 times 2u is 2u all over u minus 1. Okay, what do we do with that? As you can see, the exponents are the same. So we have to do long division again. So u minus 1, 2u. So what do you multiply u by to get to 2u? You multiply it by 2. So we get 2u minus 2. And then we subtract straight down. 0 minus -2 is a positive 2. Considering we can't make u look like a constant, that means that we have a plus 2 over u minus 1. Okay, let's put that into our integral. So we have 2 plus, and I'm actually going to separate this, guys. So this is 2 du, because we changed it, plus integral. I'm going to bring that 2 out front here. 1 over u minus 1 du. Let's see. So let's take our integral here. So this would be 2u plus 2 times ln of u minus 1 plus c. Now I'm going to plug in all my u's, and don't forget u was square root of x. So my answer is 2 square root of x plus 2 ln absolute value square root of x minus 1 plus c. Now, since d over dx, arc sine of u is u prime all over the square root of 1 minus u squared, and arctan, right, is the derivative of arctan is u prime over 1 plus u squared, we can do the following. Okay, if we see the setup, this is what I was telling you guys, like if you know your derivatives really well, you could say, hey, what looks like that by going backwards? So when we have a 1 minus u squared, and this is positive, we have a sine u, okay? When we have it in the form of 1 plus u squared, we can think of tangent. Now, just to tell you, remember the difference between arc sine and arc cosine is that negative, okay? So let's do a warm up here. Let's differentiate y equals arc sine of x over 2. Okay, don't forget this is a chain rule. So y prime equals, now arc sine, I'm going to do arc sine first, which is 1 over the square root of 1 minus the inside, which is x over 2 squared. So there's the derivative for the arc sine, but don't forget we have to multiply by that chain. So what's the derivative of 1/2 x? Well, it's 1/2. Now, if I were to simplify all this, we would see that you would have 1 over 2 square root of 1 minus x squared over 4. I'm actually going to even make this more, because if I put this 2 back in there, that would be 4, right? Because the square root of 4 is 2. So I'm going to show you one step at a time here. Square root is almost like 4 times this 1 minus x squared over 4. Now I can distribute that 4, and I end up getting 1 over the square root of 4 minus x squared. So we just did the derivative of arcsine. So what if we had to go backwards, if we were taking the integral? And that's what we're going to do down here, and I'm going to show you. So first of all, when I see 2 terms in the denominator of a square root, it should automatically check to see if it's arc sine or arc cosine. First of all, I will know that if it was one or the other, it's an arc sine because it's positive. Now, how do I do that? Okay, so the first thing what we want to do is we want to see that we have, you can see that it's squaring, right? So you have a constant squared minus the u squared. So so a in this case is going to be 2. U is going to be x because it's squared, right? U squared, so what is squared? And take the derivative, which of course is 1, right? 1 dx. So then I know that arcsine is my integral. In my inside is a u, which in this case is x, over the constant, which is 2, plus c. So if it has this set up, it's nice, easy way to go backwards, okay? So in the next one here, I don't see the square root, okay? So I know it's not arcsine or arc cosine, but if you see arctangent, what we can do is say it's a squared plus u squared. So what we want to do is remember that a in this case is our constant. Which one are these are our constant? 25 is our constant. So it's a squared. So what squared is 25? 5. U has to deal with our x. So what is that squared? So it's 2x, because 2x times 2x is 4x squared. Do our du. Du equals 2 dx. Okay, now I have to remember that I'm solving for dx. So du over 2 equals dx. So right away, this 1/2 is out front. Okay, now if I show you the integral, I'll do it this way. So we get du all over 5 squared plus 2x squared. That's my a squared, u squared. And remember, the rule here is 1 over a, which is 5. Well, first I have that 1/2 out front, times 1 over a, 1 over 5, tangent, arctangent, not just tangent, arctangent of u, which is 2x, all over a, which is 5, plus c. Of course, I'm running into the other work here. Let me rewrite this underneath, guys, so that way I have room for my other problem. So 1/2 times 1/5 arc tangent of 2x over 5 plus c. So you got to get used to the rule of being able to recognize when you're going to use it and then the pattern of how to solve it. Okay, so this should go on your note card so that way you get used to this. Okay, now we have a definite integral. So keep in mind that we're going to be plugging in. All right, well, first of all, I should know that in this case, we're going to have to deal with an arctangent, right? And so let's talk about our A's and our U's first. So A is our constant. Well, our constant is 3, but A is A squared, right? A squared is 3, so A is the square root of 3. U, again, we're dealing with 4x squared, so that's 2x. 2x times 2x is 4x squared. Take our derivative. We have du equals 2dx. Okay. Now, if I wanted to, I can move this out front and say du over 2 equals dx. So let's rewrite this. So I have my integral right here. So I'm bringing a 1/2 up front, but I can also bring that 8 up front because that's a constant, right? So 8. I'm going from 1/2 to 0. And then I have du over our A squared so our square root of 3 squared plus our 2x squared. Now I can do my rule. So remember, I have my 4 out front. Then for tangent, I multiply it by 1 over A. So 1 over A is the square root of 3. Arctangent, and it's u, which in this case is 2x, all over A, which is the square root of 3. Now, instead of saying plus 3 or plus c, I'm going to integrate it at 1/2 0. So I'm going to plug in 1/2 first. Okay, 1/2 times 2 is 1. 1 over the square root of 3. Look at your unit circle. Where is 1 over the square root of 3? It is at pi over 6. So I have 4 over the square root of 3 times pi over 6 minus, let's see, 2 times 0 is 0. 0 over the square root of 3 is 0. Arctangent of 0 is 0. 0 times 4. So there we go. And that's our answer. Whew, so much to do here. All right, let's look at this. Number 6. If you look, this is almost the same idea, right, as number 3, but there's x in the numerator, which means that this is not an arctangent. Okay, arctangent would be that there is u prime up here, but this is not, there wouldn't be an x over here. So let's do this. Let's talk about u being 3 plus 4x squared. So du equals 8x dx. Do you guys see that that covers there? So I end up with 1 over u du, which of course, what's the integral of 1 over u? It is ln. So I get ln, absolute value of u, plus c, but I know that u is 3 plus 4x squared plus c. Okay? So be careful. There are certain things you want to try first. I probably, on all of these guys, the ones without the square root, I would actually, because the square roots obviously are sine or arc cosine, but the ones without the square roots, I would try the ln first. I would say u is the denominator, but then I find out that, hey, when I solve, I don't get an x for the du, so then I go to my arc trig, my inverse trig, to be able to try that. Number 7. Okay, first of all, I noticed there's an x squared in the numerator, so it can't be our arctangent. But then I also noticed that the exponents are the same, and we learned earlier when they are the same, we're going to do long division. So I have 3 plus 4x squared, and I'm going to have that go into 8x squared. So first of all, look at your x squareds, not the 3. What times 4x squared gives me 8x squared? 2. So I get 8x squared plus 2 times 3 is 6. Subtract straight down. 0 minus 6 is negative 6. So what I'm looking at is the integral of 2 dx minus integral of 6 over 3 plus 4x squared. Okay, this one's easy, right? This is the power rule. And now look at this. This is an x squared in the denominator. There are no x's in the numerator, so it must be arctangent. Okay, so let's do our u's and a's. So a, again, is the square root of 3, because square root both of them. U is 2x. Du equals 2dx. So du over 2 equals dx. Gosh, I'm running out of space, guys. All right, let's see what we do. So we have the integral of 2 dx minus, I'm going to bring that 6 out front and that 1/2 because of this right here. So I end up with du over, this is the square root of 3 squared plus 2x squared. Now I can use my arctangent rule. So let's do power here. This is 2x minus, well, 6 times 1/2 is 3, but we have to multiply by 1 over a. So 1 over the square root of 3 arc tangent of u over a. So u is 2x over a, which is the square root of 3, and then, sorry guys, and then of course plus c at the very end. Whew, that was a lot. Of course I ran out of room for number 8. There we go. Okay, number 8, I see the square root right away. So I'm either doing u is 4 minus x squared, or I'm doing arc sine because it's positive. I know right away that it's not arc sine because there's an x in the numerator. Okay, so since I know it's not arc sine, I'm going to automatically make my u equal to 4 minus x squared. So du equals 2x dx. Sorry guys, I just want to check on something because I don't like this one either. Oh, I know what we have to do. Okay, you see, I want to run into this. Look at what happens here. So if I solve, though, I have this plus 4 still there. So it gets a little crazy. So what I'm actually going to do, because I will be doing that at one point, guys. I'm going to split this. Remember, we can split it. It's the integral of x over the square root of 4 minus x squared plus the integral of 4 over the square root of 4 minus x squared. Let me put my dx's there. So what I want you guys to observe is that in this first integral, we're just going to use our u substitution. That's where that comes into play, and that's really nice there. But here, because the numerator is a constant, we can use our arc sign. Let me get another piece of paper so I can do that work out, and you guys can see each step. That's plus integral 4 all over 4 minus x squared dx. Okay, so again, I know this is normal u substitution because there's an x in the numerator. And here, oops, I forgot that. I know this is going to be an arc sign because it's a constant up there, okay? So let's do the u substitution first. That would be u equals 4 minus x squared du equals negative 2x dx. Okay, again, I'm going to divide by negative 2 so that way that x dx can be substituted in easily. So that negative 1/2 here, I'm going to stick up front. So negative 1/2 integral of 1 over square root of u du. Now this is our power rule, right? Because think of this as u to the negative 1/2. So I get negative 1/2, which is up front. Add 1 to the exponent, you get u to the 1/2. And then divide by 1/2, which is the same thing as multiplying by 2. Okay, and I'm going to substitute back in. So this is negative 4 minus x squared to the 1/2. And then we're going to add whatever happens with our arc sign. So this is just that first part of that integral. All right, so let's go back up here. Now, because I already used u's already, I don't want to use u again. So I'm going to use v instead of u. So a is going to be 2, right? Because the square root of 4 is 2. V, I'm going to say v instead of u. V is going to be x, because the square root of x squared is x. Okay, so remember that 4 comes out front. So really we have 4 integral 1 over, this is the square root of 2 squared minus x squared, right? There's our v and our a. Okay, so when I do that integral out, I have the 4 out front. This would be arc sine. And remember, it is u over a, which v over a in our case. So x over 2. And because this is an indefinite integral, we have a plus c. Whew, a lot of work. Believe me, it takes a lot of practice to recognize this stuff. We have plenty of time. Okay, number 9, completing the square. One of the things I want to show you with completed in the square and how you know to complete the square is, as you can see in this one compared to all the other ones, it's 3 terms. Okay, so if you remember completing the square, is we have to make it a perfect square, right? So right now we have the integral of 1 over. And what we're going to do is, remember, we separate this. So this is x squared plus 4x plus something. Oh, actually, what they did, guys, is that they broke this up. This is 4 plus 4. The idea is to take this b term, remember it's b divided by 2 squared. That's how to complete the square. You get the value of 4 in this case, right? Because this one's 4. 4 divided by 2 is 2. 2 squared is 4. 4 is already in the 8. So actually, in this case, all I have to do is separate it. Okay, so right now we have 1 over the integral of x squared plus 4x plus 4 plus 4. Do you guys see how all I did was take this 8 and break it apart so that way I could have a perfect square in there? Because x squared plus 4x plus 4 is the same thing as x plus 2 squared plus 4. Don't forget the dx. All right, what did completing the square do for us? Guys, it looks like an arc tangent. No square root, so I know it's not arc sine or arc cosine. And I know there's no x's in the numerator, so I should automatically think of arc tangent. Okay, so arc tangent, I need to do a, which is our constant, right? So we got to square root that. So the square root of 4 is 2. U, well, that's my variable. Well, what is squared? X plus 2 is squared. Take the derivative, du equals 1 dx, so that's great, right? So let's go back to our rule. The integral then is 1 over a, well, a is 2, arc tangent of u, which is x plus 2, all over a, which is 2, and then it's indefinitive, so plus c. More practice, because we need more, right? Okay, example 10 here. Okay, get nervous for the fact that I love seeing the square root of 1 minus x squared, so that I might be thinking arc sine, but I see in the numerator I have an x there. So to make this simpler, especially because I have two terms, I'm going to do what we did before, which was splitting it up. So I have the integral of 3 over this square root of 1 minus x squared dx. And I see it's minus the square root, minus the integral of x all over square root of 1 minus x squared dx. Okay, so I have the same, almost the same problem that I had before, where one was going to be substitution and the other one was going to be an arc one. So if we look at here, I know this one's going to be arc sine, and this is going to be your basic U substitution. Okay, so let's do the arc sine. So this 3 comes out front, right? So I'm just going to do here to save myself some space. A equals 1, U equals x. So du equals dx. Okay, so I'll have 3. Now I might as well just take the integral right now. That's arc sine. And it's going to be x over a, so u over a, which is x over 1. So that's the first part. That was nice and easy. Minus. Okay, let's do some u substitution. I'm going to use up here to save space. So u equals 1 minus x squared du equals negative 2x dx. Divide du by negative 2x equals, oh, not 2x, just by 2, because that x is in the numerator. And then we have x dx. So what we're having here is the negative 1/2 out front, integral of 1 over the square root of u du, which of course is our power rule. We did that before. So 3 arc sine x. These two will cancel, right? So plus 1/2. Sorry guys, I'm running out of space, so I'm doing this kind of quickly. Remember, that is u to the negative 1. So when I take the integral, I add 1 to the exponent and divide by that exponent, which dividing by 1/2 is the same thing as multiplying by 2. Don't forget to substitute back in that u, which we had u is 1 minus x squared. I am so running out of space. 3 arc sine x plus, well, those two cancel, right? And then we have our u, so 1 minus x squared to the 1/2 plus c. Okay, this next one, it is complicated in the sense that you're going to ask yourself, well, how would I know how to do that? Or when she puts that in, how would I know to do that? Here's the thing, guys. This type of question will only be on the multiple choice. So if you ever run into this where you're like, yeah, I don't know what to do, take the derivative of all your answers and work backwards, okay? But this is how to do this one. So when I look at this question, I say, okay, it can't be arcsine, arctangent because nothing's squared. Well, 1 could be squared, but it's not e to the 2x. E to the 2x would be that squared. So this must be u substitution. But if you think about it, and we say that u equals ex plus 1, well, du is ex dx. And you see that if I place this u, we don't have an ex dx. So we have an issue. Here's how to do it. And yes, I understand you're not going to know this automatically. Again, keep in mind this would be a multiple choice question, and you can always do the derivative for all your answers and figure out which one works. Well, really, guys, 1 on top in the numerator is like 1 plus e to the x minus e to the x. Let that sit for a while. And just like we did in number 10 and the other one on the other page, we can split these into 2 separate ones. So I get the integral, and if you look, I'm going to separate it into this one over this and this, okay? So I get 1 plus e to the x all over e to the x plus 1 dx minus, because this is minus, integral of e to the x all over e to the x plus 1 dx. So that works for my u du. And this is 1. Well, what's the integral of 1, guys? Just x. And I have this minus. I'm going to put my u's in. So this is 1 over u du, right? Because this is my du right here. Well, that's ln. So x minus ln, absolute value of u, but what's my u? E to the x plus 1 plus c. Whew, craziness. All right, guys, try to do these problems Keep in mind that when you have 3 terms, you might be doing completing the square. Keep in mind the numerator and denominator, how they look to tell you if you're going to do U substitution or are you going to do your inverse trig. And then watch out for that. Remember how I just said e to the 2x right here? Remember, this is going to be y squared. So since I have that squaring and 1 squared, no square root, this is probably going to be an arc tangent. Okay, give it a try.